Video I'm gonna tell about electron dot structures, also known as Lewis dot structures of some compounds and elements. For example, let's take a compound of CO2. It's carbon dioxide, right? So let's draw the electron dot structure or Lewis dot structure for CO2. Now let's take its CO2. It has two oxygen atoms, and let's take carbon in the middle. So let's write the electronic configuration of the two elements. There are two elements in this compound. One is carbon and the other one is oxygen. So the electronic configuration of carbon is nothing but, what is the atomic number of carbon? 6, right? So the electronic configuration will be 2, 4. So what is the atomic number of oxygen? It's 8, right? So the electronic configuration will be 2, 6. So let's take the valence electrons of these both elements. So carbon has 4 valence electrons. So it has 4 valence electrons, right? So there are 4 valence electrons. For oxygen there are 6 valence electrons. And for this oxygen also there are 6 valence electrons. So the carbon and oxygen will try to attain the octet configuration, means they should have 8 electrons in its valence shell. So now they will share the electrons. With each other. Now carbon has 4 electrons in its valence shell, right? So how many electrons does it need to attain its octet configuration? It needs 4 electrons, right? So it takes 2 electrons from this oxygen. It takes 2 electrons from this oxygen and it takes 2 electrons from this oxygen atom and 2 electrons from this oxygen atom, and it shares it. Like it's carbon, right? It needs 4. So yeah, like this it will share. Like 1, 2, 3, 4, 5, 6, 7, 8. It has attained its 8 electronic its octet configuration by gaining 4 electrons which it needs. And how many does oxygen needs? Oxygen needs 2 electrons, right? So let's transfer, it has 2 electrons. It needs 2 electrons. So let's write it like this. It has 4, right? Yeah. Now it needs 4. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it got its 8 valence electrons. Let me show you how it shares. Like this. It shares like this, and this one also shares like this. So both the elements attain their octet configuration. So this can be written in the type of bonds also. Like see, for a clarified manner or for a neat manner, let's write it like this. Let's write again. Oxygen, it shares electrons. Got 4 electrons here and 2 electrons here. See, it has 4 electrons again, and oxygen 4 electrons. So these 4 electrons are shared and these 4 electrons are shared. So this can be written as oxygen, double bond, carbon, double bond, oxygen. So it can be written as this and this also. So now let's try another element. Yeah, the another element, let's take it as CH4. Okay, this compound has 2 what we say, two elements in its, two elements. This compound has two elements, right? So it has carbon, it has hydrogen. Let's write the electronic configuration of this both elements. Carbon, as we know, it's 2, 4, and hydrogen, it's only 1. So only hydrogen will try to attain the duplet configuration. It's an exception, right? So only this hydrogen will try to attain duplet configuration. Yeah, so let's it has 4 hydrogen atoms. So let's write C and H, 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 and H. And carbon has 4 valence electrons. So let's draw that 4 valence electrons. 1, 2, 3, 4, and it needs more 4 electrons to complete its octet configuration, and hydrogen has 1 electron, so 1, 1, 1, and 1, and hydrogen needs to attain the duplet configuration, right? So what it will do is, hydrogen will share its 1 electron and carbon will share its 1 electron to hydrogen, such that hydrogen attains its duplet configuration and carbon attains its octet configuration. Let us see how. Yeah, carbon shares this electron to hydrogen and this electron to hydrogen. It has 4 hydrogen atoms, right? Yeah, so there the hydrogen has attained 4, means it has attained its duplet configuration. Now what about carbon? Now let's see for carbon. So hydrogen, each hydrogen atom shares 1 electron to the carbon atom, which means it has 1, 2, 3, 4 electrons already. It has 1, 2, 3, 4 electrons already. So hydrogen it needs 4 electrons to attain its octet configuration. So hydrogen shares this electron, this hydrogen shares this electron, and this electron. So there are 1, 2, 3, 4. Yeah, and it will look like this: 1, 2, 3, 4, 5, 6, 7, 8. Carbon has attained its octet configuration and hydrogen has attained its duplet configuration. Yeah, so let's write it in the type of bonds. Yeah, C, H. This is what we have seen here, right? So there is a single bond, one pair, as there is only one pair of electrons, only single bond will be formed. So C is single bond H, single bond H, single bond H, single bond H. Yeah, this will be the electron dot structure, or we can write in type of this or in type of the bonds formed. Now let's see another example. What can we take? Let's take Cl2. Let's take Cl2. Cl2, right? So chlorine, it has only one element, chlorine. Its electronic configuration is 2, 8, and 7. Okay, let's draw it now. Cl, there's 2 Cl's, right? So Cl, and let's draw the electrons now. 7, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, right? So this chlorine needs another 1 electron to complete its octet configuration. It needs only 1 electron to complete its octet configuration. So this one electron and this one electron will be shared by each other to attain the octet configuration. Like, let me show. Like these two will share each other. Like so it will become 1, 2, 3, 4, 5, 6, 7 and 8, and this chlorine will have 1, 2, 3, 4, 5, 6, 7 and 8. So chlorine has attained its octet configuration. So this can be written in type of bonds like Cl, Cl or Cl, Cl, and we can write the lone pairs. Lone pairs are nothing but the electron pairs which are not shared. Yeah. Let us try another example. Oxygen. Let's try for O2. So it has only one element, that is oxygen. So the electronic configuration of oxygen is nothing but 2, 6. So it has 6 valence electrons. So let's write oxygen, right? So it has 6 valence electrons. 1, 2, 3, 4, 5, 6. And this also same. 1, 2, 3, 4, 5, 6. So it needs another 2 electrons. So what will it do is, this oxygen atom shares 2 electrons to this oxygen atom, and this oxygen atom shares 2 pairs of electrons with this oxygen atom. Understand? This oxygen shares this 2 to this, and this oxygen shares these 2 electrons to this oxygen. Yeah, let's see how can we do it. Like this. Okay, so it will have again 1, 2, 3, 4, 5, 6, 7, 8, and this will have 1, 2, 3, 4, 5, 6, 7, 8. So in type of bonds, how can we write? Oxygen, right? So it has 2 pairs of electrons. So double bond, oxygen. Yeah, this can be written as this or this. Let's try for another. The next one is NaCl, common salt, also known as common salt. It has two elements. They are sodium and chlorine. So the electronic configuration of sodium is 281 and the electronic configuration of chlorine is 287. Let's draw them. So NaCl, right? So it has 1 electron in its valence shell and it has 7 electrons in its valence shell. So this sodium need to lose this 1 electron to attain its octet configuration, and chlorine needs another more electron to attain its octet configuration. So what will sodium do is, it will donate this electron to chlorine, and chlorine gains that 12 electron, and they both attain their electronic configuration, forming the octet configuration and forming the compound NaCl. Thank you for watching.